notice, there was a combination of several different elements in the last examples that we did. We had things like KBr and so forth. What you have is something called a molecular formula. And the molecular formula is what we have here, which it shows the number and types of atoms that are present. However, a molecular formula does not show connectivity. Connectivity is something that you'll learn about later, but really, there's multiple combinations of things that are C4H10. Okay, all of the white atoms right here are hydrogens. All the black atoms are carbon, and the red atom is oxygen. And if you can think, there's multiple ways of trying to organize them. These are just two of them, but there's probably at least 100 different ways of trying to organize these 15 atoms into the different shapes that would actually work. So because of that, the molecular formula does tell you some information, but it doesn't tell you everything. In this class, we're going to be focused primarily on the molecular formula. This idea of connectivity we'll talk about briefly, but it is a little bit beyond the scope of this class. But we do want to talk about things in terms of the molecular formula. We want to ask to know how much oxygen is there. And there's a lot of different ways you can say. You can say, well, for every molecule, you have six oxygens for every one molecule. And that would be a fair way of saying how much oxygen there is. Another way is saying as the percentage of the molecule. So you can say, well, there are 6 molecules of oxygen and there are 15 total atoms. So you can record it as a percentage. Or the most common way is the percent mass. So how much of the mass of this molecule is due to the oxygen? And you can see that we talked about here. You've got the idea of you've got 6 oxygen atoms. You have 30% of your atoms could be, I don't think that's quite right. Yeah, that's about right. 30% of your atoms are oxygen atoms. But this is the one that's really important, the idea of percent composition. In other words, what is the mass composition of your particular particle? And how you find the mass, the percent composition is pretty easy. Anytime you find the percent of something, it's part over whole times 100. So when I give you a compound like C4H10O6, the first thing that you have to do is you have to find the whole. And we've done this. This is what we did when we found the gram formula mass. You have carbon. Carbon is a mass of 12. There are 4 of them. Hydrogen has a mass of 1. There are 10 of them. Oxygen has a mass of 16. There are 6 of them. You multiply these values out. When you get those values, you add them. And when you add them, you get the total, which is 154. Now, you would take the individual part, like for carbon 48, and divide it by 154. Of course, you'd want to multiply it by 100 to turn it into a percent, and then you get the percent by mass. Now the percent by mass should add up to 100% whenever you look at all of the atoms that are in the molecule itself. So this does take a little bit of practice, it takes a little bit of skill to develop, but let's work a couple of examples out just to see how it goes. The first one says, what is the percent composition of sodium in sodium sulfide? So we set up our whole thing right here where we have sodium and we have sulfide. And in this particular situation there are 2 sodiums. And the sodium is about 22.99 depending on your periodic table. And that right there is about 45.98. I'll go ahead and switch colors so it's easier to see. And then you have sulfur. Sulfur is, you have 1 of them, and it's about 32.06 per sulfur. 1 times 32.06 is still 32.06. Now I can solve for the total. All I would have to add is this 2 pieces together. Once you add those 2 pieces together, you get the total of this thing is 78.04 grams per mole. So remember, this right here is the total molecule has 78.04. So if I want to find the percentage of each individual one, I would divide it by 78.04. Now in this particular example, I'm actually looking for what it is for sodium. So I'm not really concerned with sulfur. And you had to recognize that sodium was Na and sulfur was N, or excuse me, S. Take this thing, divide them, multiply it by 100 to turn it into a percent, and you end up with sodium represents 58.92% of the mass of this particular molecule. Okay, this is called percent composition by mass, and we will revisit it throughout the year. So it's good to have a good jump on it. If you don't quite understand it all the way, spend some time, practice with it, and it will come up again before you're actually responsible for it. Now, what is the percent composition by mass of oxygen in barium sulfate? So you have the idea of barium sulfate. So we start barium. There's one barium. And barium's about 137.27, oh, excuse me, 0.33. Okay, then you have sulfur. And we've done sulfur, so we know that it's 32.06. And now you have oxygen, and there are 4 oxygens, each at 16.00. So 64, 32.06, and 137.33. Take all those values, add them up, and when you add them up, you get an even 154. It's about 154. No, it's more than that. Let's go ahead and use a calculator to see what it is. You have 137.33 plus 32.06 plus 64, and it's actually 233.39. So if I'm trying to figure out the percent composition of massive oxygen, you would take the mass of oxygen, which is 64, divided by 233.39, and when you do that, this thing comes out to be about 27.42% oxygen. And the final example that we have is thymine. It says thymine is one of the 4 nucleotides that stores genetic information in DNA. What is the percent composition of nitrogen in thymine? So there's a whole bunch of stuff here in thymine. So let's go ahead and start it. You have carbon. Which is 1 times 12. And it's going to go ahead and simplify these for now. 1 times 12. You're going to have hydrogen. Oh, excuse me, it's not 1 times 12, it's 12 times 12, because there are 12 carbons that are there. And that makes this 144. You have hydrogen, which is 1, that's the atomic mass, but there are 17 of them, which makes this about 17. Oxygen, there's only 1 of, and it has a mass of 16, so you get 16. If we keep going, we've got chlorine, which has a mass of 35.45. We'll call it 35.5. And there is only 1 of those. 35.5. Okay, next you would do nitrogen. And nitrogen there's actually more of. It's 14 times 4, which is 56. And then finally you have sulfur, which is 32, and there's only 1 of. When you take these values and add them up, you get the total mass, which I did with a little bit more precision to be 300.81. The last thing that it asks you to do is what is the percent composition of nitrogen? So I identify nitrogen as my 56, divide by 300.81, multiply by 100 to turn it into a percent, and I end up with a value of about 18.63%.